to another video on my YouTube channel. This time it's about the CNC machine I built for Spinogy. It's the SOROTEC Heavy Gantry machine. Got all mounted and wired up, and finally the control cabinet also is finished. So I took the time and put the spindle controller also on the wall. And yeah, actually the last couple of days I was pretty busy doing the last things. I still have to do some small things or some minor things to finish this all off, but I managed to get all the servos running. They are pre-tuned, so it's not the final tune, but in this video I actually want to show you guys how this machine performs with the standard servo settings, because I really didn't dig all too deep into the servo settings, but I will do this in the next coming days. So it's actually running pretty smooth. Everything is working fine. And yeah, I now wanted to show you guys the control cabinet, what I've done to this, and then we will make some chips and some ash wood. So yeah, let's get it started and stay tuned, guys. Okay, for the shots of the control cabinet I had to take you guys off of the tripod. So yeah, let's walk you guys through this. As you can see, here are the buttons and switches, on and off, e-stop, and the main switch. Power comes from down there up to the main switch, and then goes further on to this one right there, to this contactor, and to the AC reactor, and then it just basically spreads out to all the different components in the cabinet. Right there is the CNC 760 from Eding CNC. Two power supplies, 24 volt. The one on the right side is just for the Z-axis servo for the brake, because I wanted to have a separate power supply for the brake. Yeah, then some noise filters and another set of contactors, and then of course the drives. Underneath the drives are small noise filters, and yeah, and then here we have those DB25 modules. I actually wanted to use them because this makes wiring the signals from the CNC 760 to those modules a lot neater, in my personal opinion, because then you just have to wire up between those two connectors from the module to the drive. So yeah, it's actually a pretty neat solution. Of course I overdid it a bit. As you can see here, I have to touch this one up again. I sleeved all those cables just to make it look nice and just really neat. And as you can see here, the relay on the very top, this is the one for the brake. This actually works together with the system ready terminal on the CNC 760. As the system is ready, the brake is released because the motor has power. And if there is an e-stop event or a drive error from the servos, this terminal will shut off, and then the brake on the Z-axis will trigger. So yeah, this is basically all the magic. Yeah, I think came up pretty nice. Used all those connectors and screw terminals. Also the Ethernet plug has a separate throughput. So yeah, actually I'm pretty happy with it. What the guys from Spinogy will do is to drill a hole in the side of the cabinet to mount a fan to allow some airflow, and also in the top right of the enclosure, because I actually don't have this big of a hole saw, so they actually have to do it. But yeah, I think the cabinet came out pretty nice and everything's working very nice and well. So yeah guys, let's make some chips with this machine and see how she performs. Okay guys, here goes nothing. Just let me turn on the spindle. Will get pretty noisy because of the fan, because this is the prototype spindle which is air cooled. But yeah, fixed it all down, double-sided tape. I won't go all the way through the material. I will leave 3mm in between the wasteboard and the ground of the stock, if this makes any sense. But I won't go all the way through the material. Yeah, so fingers crossed, and let's see what the first chips with this machine look like. Actually dialing down the feed rate just in case something goes wrong to about 50%, and let's hit go. Okay, looks good. Turn it up. This is 4.5 meters feed rate, sliding down the surface. Can we go faster? I think so. .75 meters feed rate. Can we go even more faster? Minute feed rate. Oh man. Dial it back to 100% feed override, because now the adaptive gear will come. Well, no, I think that's too safe. Now next step is adaptive clearing with 10mm end mill, which I already use for planing the wood. So yeah, let's see what happens. Wow, it really cuts so smooth. Feed rate of 4.5 meters a minute. And I'm actually not going any faster because it's fast enough. Yeah, wow, I'm pretty amazed. Look at this. Okay, let's turn it up a bit. Around about 6.5 meters a minute. Still 6.5 meters a minute. Wow man, this thing really works like a charm. Now it's time for some engraving. Let's see how it goes. So yeah guys, this wraps up this video. I know it's been a long one, but I would call this mission accomplished because this machine really is running super smooth and really nice. Even with the standard or basic servo tuning settings that I applied to the servos, really runs super great. This machine truly is capable of some high feed rates and large depth of cuts and width of cuts. Yeah, it's pretty sturdy. Although I really like the concept of this machine from SOROTEC, but the execution isn't that great, to be honest. And this is my personal opinion, but at the price point on which this machine comes, there really shouldn't be any flaws in the parts that you get. For example, I really don't like the cheddar marks on those gantry side plates that are there. This is obvious. I know this may sound to someone else like it's not big of a problem, but at this price point the machine should be top notch. Also, what I discovered during building or first running the machine, that one bearing on the loose side, on the floating side, has some play in it. This wasn't caused by me, because the other side is just fine on the floating side, but you actually can wiggle it a bit, just a couple of tenths, but you really, or it gets audible when the machine moves at rapid speed back to G28 in parking position. Actually, I can show you guys. just let me jog it forward. I know the ball screws really sound rough. It's because I haven't greased them yet, but I wanted to do the first time machining with it, just in case there is any other problem. But now just let me ratchet her back to G28, and then notice at the end of the movement how you can make out some noise, some how do you call it? Vibration noise, I guess. This one. This comes from this ball screw. If I tap the ball screw on the other side, it's rock solid, as you can hear here. And this is, and I really was wondering what this noise is until I had a look at the floating end of the ball screw, and sure enough there is some play. The inner bearing ring has play in it. It isn't from the seat, from the bearing to the ball screw. It's actually inside the bearing. The inner ring of the bearing has play. So this is what this is causing. Those are some minor issues, and yeah, but I think those issues really shouldn't be there for a machine that's this size and especially at this price point. But the concept really is great. The machine is really sturdy, very stiff, and it truly is dynamic with the right motors on it, as you can see. And this is why the guys from Spinogy thought it would be a great idea to make a direct drive conversion kit, which I made for them. And yeah, it works out really well, and I hope the guys really enjoy it, but I think so. So yeah, guys, I will put some pictures now at the end from the small tray that I did. It's actually for the guys from Spinogy. I have to do 3 more of them because there are 4 guys that are running the company, and I'm going to hook them up with some catch-all trays with their logo in it. So yeah, guys, thanks for watching, and see you guys in the next one. Bye bye.